Namaste. We present Arogyam, an Ayurvedic herb identification, taste analysis, and adulteration detection device. Today, identifying the authenticity of Ayurvedic herb is a major challenge. Many raw materials are adulterated or mixed, and subjective taste testing lacks consistency. Arogyam solves this by combining computer vision, chemical sensors, and a taste profiling module into a single device. Our prototype is built on a Raspberry Pi 5 with an Arduino Uno handling the sensor. We have used pH sensor, TDS sensor, turbidity sensor for liquid sample and a TS3200 color sensor. We have also added a custom taste profile array to identify the 6 Ayurvedic tastes: Madhura, Amla, Lavana, Katu, Tikta and Kashaya. We have powered our prototype with a kiosk dashboard. It displays live sensor readings, identifies the herb, highlight the taste profile and check for adulteration. So this is our home page. You can see recent analysis, quick action tab and system step. Let's go to analyze herb. In analyze herb we can analyze any herb, whether it's solid or liquid. We can also, if it is solid, we can access it through our camera and capture the image and analyze the adulteration value of the solid object. Now, camera will take 2 to 3 seconds to ready. So now you can see the camera is ready and giving us the image. You can clearly see that. Let's go to database. In database we can add any herb through cloud support. We can also delete the herb. We can change anything. Now in report section you can generate basically 90-day or forever report. Analysis history is basically the analyzing of the herbs. And in system state we can select of the database that we want for 90 days or 1 year or forever. We can also tune our sensors, calibrate it. So let's taste some solid herb. We have taken tulsi leaves and we are going to place it under camera angle. So we have placed it under direct camera and we will take the pen. So we have to go to analyze herb, select the herb that is tulsi, select the state that is solid. Now we have to select comprehensive analysis because it is a solid herb. We can't identify its pH value or taste analysis. We have to wait for few seconds for camera to get active. So what happens if we capture the image is that it will compare the image that is being captured with the CNN model where the previous images that are being trained to calculate the adulterated value. So you can see we have got a 91% accuracy on this. Means it is 9% adulterated showing, but it is good for consuming. There are 3 levels of camera adjustment in the Arogyam device for the better accuracy. Time to have a taste on liquid also. So let's take some water, approx 250 ml or 300 ml. Put some pinch of haldi in it. Then we have to stir it for 2 to 3 seconds or say 4 to 5 seconds maximum, so that it will give some value in all the sensors. Now we have to put this haldi through the funnel into our prototype. Filling it will completely cover our sensor props, that is pH, turbidity, TDS and the color sensor. Now we can go to dashboard. Okay, let's focus the light first. Okay, so now we have to select the herb that is turmeric with a state that is liquid. Now we can change the liquid capacity, that how much water we have added to the herb. Then what we want to taste. I want to taste analysis of this. Okay, so let's continue to start analysis. It will take 4 to 5 seconds. It will compare all the sensor data that has been fed to the database. Okay, so you can see taste profile Vasa has been calculated based on some ratio, okay, of the 6 profile of the 6 taste profile basically. You can also see the pH, TDS and turbidity values. Now as we have seen the working of the prototype physically, let's also understand how this data is processed in the system. Sensor data is collected via Arduino and transmitted to the Pi. The Pi runs a Flask backend that fuses the data with AI models, a CNN model for image recognition, and a classifier for taste and chemical profiles. What makes our prototype unique is the fusion of modern electronics with Ayurvedic principle. This achievement was possible because of my team's collective effort. Yes Raj, front-end developer who built the UI UX, Rajat Mitra, 3D designer who shaped the prototype. Sahin Molla, backend developer who connected the database. Priya Kumari Singh, market research and pitching format. Tushar Biswas, researcher who collected the open source data for AI training. And myself, Roshan Kumar Yadav, who designed the circuit and developed AI for test profiling and adulteration detection. Thank you.